you just need to change the fact that we're going to spin the penny 50 times and it came up heads 35. The reason I'm spinning the penny rather than flipping it is because you're actually more likely to get bias if you spin it, because if one side is heavier than the other and the side that has Lincoln on it, I think is supposed to be a little heavier than the other side, then it won't come up 50-50 if you do it that way. So you've heard that a penny will land 50% heads and 50% tails. I spun a penny 50 times. It came up heads 35 times. So that's too many times, right? That would be a 70% rate. So first thing we're going to do, identify the population and the parameters and the statistics. I'm going to make the population all spins of a penny. If I stated it the other way, I would have to say all pennies. But we're just reusing the penny. The parameter would be the true proportion of whether it will come up heads or tails. Okay. The sample is 50 spins of the penny, and the statistic there, in other words, the p hat, is going to be 35 divided by 50, which is 0.7. And then we're going to change this. This is not 14 out of 20. This is going to be 35 out of 50. So there's two reasons why the penny would come up 70%. Either it's just random variation. You could call it luck, bad luck, good luck, whatever, but I don't. The second possibility is that the penny is biased, and maybe it's biased because one side is heavier than another, and when it's spinning, it tends to fall toward the side that's heavier. Okay, to test the penny, we're going to assume it is a 50-50 penny, and we're going to look at the likelihood of not 14 out of 20, but 35 out of 50. Here's where we're going to deviate, because this is a video in a classroom. Now would be the time that I would pass out pennies, and I would say, okay, for the next 5 to 10 minutes, please spin your pennies and see what happens. We're going to have to simulate. So I've created a simulation on Excel. I know it just looks like a lot of numbers, but the first simulation of 50 rolls of a penny came up with a percentage of 56%. The second one came up as 62%. So we could use those numbers, use a random number table. What is your sample proportion? One time we got 56%, and it says repeat for another sample of 50 spins, and that was 62. So just give you a flavor of, if 35 out of 50 is 70%, and I've done it twice, then you already get a sense that it's pretty rare to get 70% heads. This is why we would want the entire class to do it, to get a larger sample. And that's why I have a screen that's absolutely full of numbers here, put together just like our project was, where I have random numbers in one column, and then the next column where you see the zeros and ones, that's just counting whether it was a success or a failure. To be heads or tails. But the real interesting part for us is going to be if we go over here, that's Facebook, we go over here to STApplet and we look at the dot plot. So looking at the dot plot, how rare is it to get 70%? Well, I don't even see 70%. According to this sample of 50, it was impossible to get 70. We would call that the p-value. The probability to get what we're looking for was 0. So that's telling us something. It's telling us that of our two possibilities, was it random variation or did we have a biased penny? Telling us if we get a result like that, we probably have a biased penny. So number 5 is where we would put all of our data together as a class. We're just going to kind of fake it here, that we saw that it ended around 35 and maybe 65, and there was, a pattern of dots that peaked around 50%. Each dot there represents a spin of the penny. Based on the simulation results for the whole class, how likely is it for a 50-50 coin to land heads up 0.7 when rolled 50 times? It is 0. Impossible, according to that roll of 50. Of course, it's not impossible if you do it hundreds of times or thousands of times, but For our single result, our single sample, if you will, it was not possible. So based on your answer to question number 7, does the observed p hat equals 0.7 result give convincing evidence it's not a 50-50 coin? Yes, it is convincing. That's what statistical evidence is. It says it's so rare, it's unlikely to have happened. Not a 50-50 coin? Or is it plausible that a 50-50 coin can behave this way by chance alone? No, it's not plausible. We didn't even get a single result. Now, we got 0, but really the cutoff we'd be looking for would be normally 5%. We said 5% will be our standard for what is rare. Even if it happened once, 3 ideas. Number 1, the hypotheses. Okay, the null hypothesis equal to whatever in the context of the problem is situation normal, nothing to be alarmed about. Things are happening as they should be happening, or as they have been happening. This alternative hypothesis. We have 3 choices here. We can say P is not equal to a number, P is greater than a number, or P is less than a number. Which one you use depends on the context of the problem. We're not quite to that point where we're ready to calculate our own p-values. Okay, number 2, this p-value. So here's how you interpret it. You say, assuming, and whatever the null hypothesis context is, I'll go back and I'll read this for the coin problem we just did. There is a, whatever the p-value is, probability of getting either, if it's a proportion, the p hat value. P hat just simply means a proportion from the sample, or x bar if you're talking about averages or means, purely by chance. So let me reread that with the coin problem in place. Assuming the coin is fair at 50-50, there is a 0% probability of getting 70% heads purely by chance. Number 3, if the p-value is greater than or equal to 5%, remember 5% is our standard for rareness, we're going to fail to reject. But if the p-value is smaller than 5%, then we reject the null. And this then becomes convincing statistical evidence. And I'm going to get you started a little bit on the A part. Your null is what has been accepted as the true value before this problem even started. And it said nationally the proportion of red cars on the road is 0.12. So that's what we're starting with. That's our null hypothesis. Off to the side, you need to define what P is. And you just get it from reading the paragraph. P is the proportion of red cars on the road. Your alternative hypothesis, and I'm going to leave part of this blank, put a little red box here. You have to determine if it's not equal to, greater than, or less than. So from the context of reading the story, are we interested in just saying it isn't 12%? It's more than 12%, it's less than 12%. And so once you put in, this will be not equal to, or less than, or greater than, you still compare it to 12%.